All right, lesson 10, parallel lines in the plane. Our aim today is let's perform translations on lines. That's our first activity, is translating lines. So for number 1, draw any non-vertical line in the plane. Draw 2 possible translations of that line. So a vertical line just means up and down, just like these lines you see here on the grid. All right, they are going to be looking very much like the y-axis. So I'm just going to draw a rather simple non-vertical line based off the equation y equals x. It's one of the simplest linear equations you can have. So my formula for a linear equation is y equals mx plus b. So if I'm modeling it off of this, m, which would be the slope, in this case would just be 1, because 1 times x is just x. So I could also write this as y equals 1 times x. The y-intercept, in this case, there's no y-intercept, so it would be plus 0, which means it hits, well, that was actually inappropriate. There's no y-intercept, it just hits the y-axis at 0, so there actually is a y-intercept present. So I'm going to go to this origin right here, that's the y-intercept. Then I'm going to follow my slope, which is 1, or as a fraction is just 1 over 1, which means rise 1, run 1. And I'm just going to keep finding points here on the grid. All right. If I want to go backwards, I do the opposite. Down 1, left 1, down 1, left 1. Keeping that same constant slope here. And all these points should be collinear. All right, so they want me to perform 2 possible translations. So one translation I could do would be, if I'm starting with my point xy, I could then, I could add to the y. I could do x, y plus 2. So that's, I would imagine that rises and makes it go up 2. All the y coordinates are now going to move up 2. So this y coordinate is going to go here, up 2. This y coordinate is going to go up 2. This y coordinate is going to go up 2. All right, so that's going to happen to all of my points here. So if this is, let's call this y. Let's call this y1. It's a different line. Okay, let's try another one. Let's call this y2. Let's say we started xy, and I'm going to move all my x coordinates minus, let's do plus 3. Keep the y's the same, keep it simple. So I'm going to move every x coordinate over 3. All right, now I'm going off the grid, so I'm going to start over here now. 1, 2, 3. 1, 2, 3. 1, 2, 3. So these are the images of that original line y equals x after a vertical shift and a horizontal shift. All right. Find the slope of your original line and the slope of the images. Well, I already know the slope of my original. Slope of y equals x is 1. All right, let me see if the other slopes are the same. So I can do that by finding the rise over run. Start at a coordinate, up 1 over 1, up 1 over 1, up 1 over 1. So y2 also has slope 1 over 1 or just 1. Let's see if the same holds true for y1. Up 1 over 1, up 1 over 1, up 1 over 1. So we can also say y1 also has slope 1 over 1 equal to 1. And if you remember, when lines have the same slope, which all these 3 lines have, we say they're parallel. So we say y is parallel to y1 parallel to y2. That's all for 10.1.